For 10.2, we are going to be looking at the law of sines. And what law of sines tells us is if we take a corresponding set of angles and sides. So for here, we have, say, angle A and side A. If I took the sine of that angle and divided it by the side A, that will be equal to the ratio of taking the sine of angle B and dividing by side B. And then the same for angle C and side C as well. So law of sines works for any non-right triangle in order to help us find missing information from a triangle. And so the types of triangles that we are going to be using for a law of sines is when we have angle, angle, side, angle, or side, side, angle. So what all three of these types of triangles have in common is that whenever we have these laid out, we always have one set of corresponding angle and side. So you might have both angle A and side A. You might have angle C and side C. No matter what, you're always going to have that one set of corresponding parts to the triangle. Now, what's special if I'm taking a look at side angle in our notes, there's this ambiguous case. And so what happens with side angle is because the first thing that we look for is an angle, we have to look for either having one triangle that satisfies the given information. There might be two triangles that satisfies the given information, or there might be no triangles that satisfies the given information. And so this is for our ambiguous case, and we will take a closer look at that in a little bit. Okay, looking at problem 1, I'm going to first just going to go ahead and label my diagram with everything that I was given. And I'm going to recognize that the problem is asking me to find the two remaining sides. And I also notice that I have the corresponding angles and side for B. So what that means is when I go through and set up both of my problems, I'm going to always start off with sine of B, which is sine of 50 degrees, divided by side B, the 12.51. And then I'm going to plug in either my corresponding A or C values. Since I'm given angle A first, let's go ahead and just solve for side A first. So sine of 36 degrees over missing A. From here, what I like to do is cross multiply. And then I like to solve for A algebraically first. And the reason that I do that is so I can plug this whole entire fraction into my calculator and get the most exact answer that I possibly can without worrying about any rounding issues. And so when I do plug this in, I end up getting that A is approximately 9.6 centimeters. So now we have to go through and find side C. But before I can find side C, I must first find angle C. In order to find angle C, remember that all angles of a triangle add up to 180. So if I go through and subtract the two given angles from 180 degrees, we know that angle C should be 94 degrees. Now that I have that information, I can go back to finding my side C now. And the way that I would do that would, again, I was given my B information. So I'm going to set up that first and set that equal to my C information. Do some algebra and know that I have to type this into my calculator. For side C, and when I do that, I get C is approximately 16.3 centimeters. And there we have it. Now, for a problem like number 2, again, I'm going to start by just labeling my diagram. So I'm given that side A, that side B is 30.12, and angle B is 66 degrees. Okay, so we have that. We have to find the remaining sides and angles, so we must go through and find side C, angle C, and angle A. Okay, so like we started our last problem, the first set of information that I'm going to start with is where I have both of the same variable. Here I have both angle and side B. So we're going to start off sine of 66 over side B, that 30.12. And we're going to set that equal to, since we're given side A, let's go ahead and say sine of angle A over 29.45. Now, if you remember, we are solving for an angle first, so we must look for ambiguous cases. Okay, so what we're going to do first is just solve this problem as much as we can, and then go through and look for a possible second triangle. So if I go through and first solve for angle A, I'm going to end up getting that 30.12 times sine of A is equal to 29.45 sine of 66. And so I get that sine of A is this algebraically. And when I plug that into my calculator, I say that sine of A is approximately 0.893. Now, that doesn't make sense to be an angle, but remember that's because we're not done yet. I do need to still go through and take the arc sine of this. In order to get angle A. And when I do that, that is approximately 63.3 degrees. Okay, so, and I know this is angle A, and we'll label that. Now that I have angle A, remember all three angles of a triangle add up to 180. So I'm going to do 180 minus angle A we just found, and minus B. So I know that angle C should be 50.7 degrees. And then our last piece of information that we're looking for is side C. So side C, again, start with the givens. You were told that sine of 66 over 30.12. And now we're going to say, okay, sine of 50.7 degrees over side C. Do a little bit of algebra, and we know that C, we're going to plug into our calculator this fraction. And we end up getting that side C is approximately 25.5 centimeters. Now that we have our first triangle found, what we need to do is go and look for that second case triangle, because we do have a side-side angle as our given information. So what we are going to do is we are actually going to backtrack to the first piece of information that we found for the first triangle, where we said that angle A was 63.3 degrees. Recall from chapter 9, where when we take the arc sine, we are limited to answers only in the first or the fourth quadrant. For all of these cases, since a triangle must have a positive answer, all of them should be first quadrant angles. But also think about, what other quadrant is sine positive in? Well, it's positive in the second quadrant. So for our second case scenario, what we are going to look for is a second quadrant angle that satisfies where sine is 0.893. So for that second quadrant angle, what we are going to do is say that our new angle A should be equal to 180 degrees minus that 63.3 degrees that we found. And so angle A is going to be 116.7 degrees. Okay. The next thing that we did was we went through and found angle C then. So angle C, remember, is going to be found by doing 180 minus angle A minus angle B that was given. And so angle C, when I do that, should be negative 2.7 degrees. Now, think to yourself, does it make sense to have a negative angle in a triangle? It does not. So since that does not make sense, we can say that there is no second triangle. Continuing on with problem 3, first thing I always like to do is label my diagram. And I'm going to notice, okay, I have all of my A information. So the first thing that I'm going to set up is sine of 23.1 degrees over 2. And that should be equal to sine of B over 6. Now remember, the first thing that I'm looking for is an angle. So we must look for ambiguous case. This is a side angle. So we're going to look for that second case scenario. Before we worry about the second case that we might have, let's go ahead and finish the first triangle that we have started. So I'm going to go through and again, do my cross multiplication. And solve for just sine of b algebraically first. And when I plug that into my calculator, I get that the sine of b should be 1.18. Next step would be to go ahead and take the arc sine of 1.18, but do take notice, sine can only be between -1 and +1. Since this is outside of that range, whenever I take the arc sine, your calculator is going to tell you error. Whenever that happens, we are going to have no such triangle. Because this first triangle doesn't exist, we don't even have to worry about then going back and checking for a second case. Moving on to problem 4, again, always start with just labeling your diagram. With the given information. That way it might help you to notice, okay, we have both angle and side A, so starting law of sines with that information. We have side B, so let's look for angle B first. Now, remember, looking at both the diagram, it's a side-side angle. And because we're looking for an angle first, we must look for a second case. So make yourself a note so that we remember to come back to it later on. In the meantime, let's go ahead and finish up the first triangle if we can. So what we already have set up, doing some algebra, we get that sine of b is approximately 0.589. And so when I take the arc sine of that, angle B is approximately 36.05 degrees. And this is the first thing that we've found. Next, what we're going to do is we're going to look for angle C. So we're going to say, okay, as always, angle C, take 180 and subtract the other two angles that you already have. And so angle C should be 120.85 degrees. And then the last thing that we need to look for then to find the remaining sides and angles is side C. So we're going to set up sine of 23.1 over 2. Sine of that angle we just found. Do some algebra, we get that C should be approximately 4.4 feet. And for this, we have our first triangle. Don't forget to go back and look for the second case. what we're going to do here is look for the second quadrant angle. So in this case, the first angle that we found was angle B. So angle B, our new one, will be 180 minus the first one that we found. And so angle B is going to be 143.95 degrees. Now we're going to look for angle C again. So we can do 180 minus the two angles that we now have. And for this case, angle C should be 12.95 degrees. This is the first problem that we've seen where both of our new angles work out. They are both positive. So what we're going to do is finish up our second triangle and find side C now. So we're going to do that by first setting up sine of angle A over side A. And we're looking for our new C. So sine of angle C, this new one, over our missing C. Do a little bit of algebra work here, and we get that C should be approximately 1.1 feet long. Okay, so for problem number 5, I feel like we've gone through enough practice problems where you should be able to attempt this problem by yourself. So go ahead and pause the video here, and then once you're done working out the problem, I will come back and show you the answers. Okay, so hopefully you have now gone through and solved for the remaining sides and angles of this triangle. Hopefully you did notice that the original setup was a side-side angle. We solved for an angle first, so you did need to look for a second triangle that would work. So for the first triangle, we found that angle A was 45 degrees. That made angle C 105 degrees. And then side C should be approximately 1.93 units. The second triangle, remember we find that by doing 180 minus the first angle answer that we got. So 180 minus that 45 gave us our new angle A was 135 degrees. Therefore, angle C should have been 15 degrees. And then going off of that, our new side C would have been approximately 0.52 units. Moving on to a problem like number 6, let's go ahead and first take all of the information that it gives us and put it in our diagram. So it tells us that this angle and this angle here are 24 degrees. I have a 48 degree angle there. PT is 1, RS is 2, and our job is to look for the length of PR. Now, in order to find PR, we need to do two different things. I'm first going to find PQ. And the way that I'm going to do that is I'm going to recognize that the triangle PQT is a right triangle. So we can set up tan 24 degrees should be 1 over my side length PQ. If I do a bit of rearranging here, PQ should simply be 1 over tangent of 24 degrees. And so when I plug this into my calculator, we should get that PQ is approximately 2.2, let's go to 3 decimal points, 2.246 units. Okay, so we found PQ. Now let's go through and find QR. Now, triangle QRS is not a right triangle, so we need to do a little bit more work with this. But what I notice is that I can find angle S by subtracting the two other angles in this triangle from 180. And so when I do that, angle S should end up being 108 degrees. And so now, if you notice, we have two pieces of information, an angle and a side across from each other. Plus, we have an angle and the missing side that we're looking for. So we can go ahead and set up law of sines to find QR. So I'm going to set up sine of 24 degrees over 2 should be equal to sine of 108 degrees over that missing side, QR. Go through and solve for QR. And so when I plug this in, I end up getting that side QR is approximately 4.677 units. And so I know that PR should just be the sum of these two sides that we found. And so that's going to be approximately 6.92 units.